Hi everyone, welcome back to Code Meets World, where I'm solving all 150 NeetCode problems one video at a time. In the last episode, I looked at the diameter of a binary tree problem, which was super interesting. And then if you're following along with the channel, you will have seen that I redid all three of the videos in the trees category. To show a better solution than the one I originally came up with. And the reason I did that is because my solutions were a bit chaotic and not as neat and tidy as they could have been, and I needed to find and show you the nicer solutions so that the rest of the tree problems would be a lot easier. So anyway, in this episode, we're going to move on to the balanced binary tree problem. Okay, so very short instructions this time. Given a binary tree, determine if it is height balanced. So what does that mean? A height balanced binary tree is a binary tree in which the depth of the two subtrees of every node never differs by more than one. The depth of subtrees. Okay, so I think what that means is, if we look at this one, the depth, if we look at the 3 node, the depth of the left subtree is 1, and the depth of the right subtree is 1, 2. So the right side is 2, the left side is 1. Those differ by 1, so it should be balanced, and it is. This one, on the other hand, looks unbalanced, right? Because on the right, the depth is 1, on the left it's 1, 2, 3. So 3 and 1 are more than 1 apart. So that one should be false. And an empty tree is true. Okay, great. So let's hop down to the whiteboard and talk about how to solve this one. So, again, like the last videos, the values in the nodes don't actually matter, so I'm not going to write them. Right, so like I just explained, we're curious about how deep the tree is on the left, and then how deep it is on the right. So this is 1, this side is 2. If they are 1 apart or less, then it's balanced, which this one is. So this seems like a problem that we can solve, again, using our previous problems in this trees category, where we look for the depth of a subtree. So what I'm thinking we do in terms of the algorithm to solve this is, starting at the root node, find the depth of the left subtree, which would give us, in this case, 1. Then we would want to find the depth of the right subtree, which in this case would give us 2. And then we basically need to do, so if this was x and this was y, we need to do x minus y is greater than or equal to 1, the absolute value of x minus y. If that's true, then it's unbalanced. Hopefully that makes sense. What I'm saying here is, if we calculate the depth of the left side and the depth of the right side, they can't differ by more than 1. So if we subtract them and then take the absolute value of that number, because we don't know which order we're going to be, so in case we do 1 minus 2 or 2 minus 1, by taking the absolute value, these both equal 1. And if it equals 0 or 1, that's balanced and that's okay. But if it's greater than 1, so I don't need the equal to sign here. If it's greater than 1, then that's unbalanced. And so that's the case that we're interested in looking at. So this seems like we take the depth and then subtract them. And I'm going to go with that solution and see if we can get that to work. So what we'll start out by doing is creating, like we have in some of the previous videos in this category, we need a function to calculate depth of a given node. And again, if you need a refresher on how I get this code, I'll link the video at the top where I explain this. But basically what we can say is if the node is null, it's none, we can return that the depth is 0. Otherwise, we return the maximum of the depth of the left subtree, the depth of the right subtree, and we add 1 to all of this. So this function here is a nice, tidy piece of code that will calculate the depth of any given node. So now that we have that, we need to do basically what I talked about on the whiteboard, which is take the left, take the right, and absolute value of the difference. So that would just mean we would want to say left depth equals depth of root dot left, and then right depth equals depth of root dot right, and then what we need to return is the absolute value, right, of left depth minus right depth, like that. And then I think I also have to handle the case where so if not root, so basically if the root is none, we just return true. Oh, I have to return true or false. Return true that it is balanced. So then I have to return if the absolute value of left minus right is greater than 1. So basically, if it is greater than 1, that would be returning, I guess, so less than or equal to 1, right? So in this case, if we calculate the absolute value of the left minus right and it's less than or equal to 1, that's great. That's perfectly balanced. And so we want to return true. And so this expression would return true. If it's greater than 1, this will return false. And that would be it's not balanced. So I think this might be right. Amazing. So that solves all 3 test cases. Oh, okay. That didn't solve everything. Let's see why. Let's plug in one of the test cases that I missed. Oh, okay. Okay, so I missed something. It doesn't just have to be... Oh, the depth of 2 subtrees of every node never differs by 1. In my explanation, I was only talking about the case where we're looking at the root node. I'm only passing in the root node here, but as you can see in this case, if we look at the root node, the depth is 1, 2, 3 on each side. So it's balanced. And my code returned true. But the expected value is actually false, because let's look at the 2 node here. The depth of the left is 1, 2. The depth of the right is 0. There's nothing there. Those differ by more than 1. So this is actually not balanced. So I am not handling that case. I need to check all the nodes. So this is very similar now to the last problem that I solved for the diameter of a binary tree. And that's where I had to keep track using an init function of a global variable. And so I will call it self.unbalanced. And we'll set that equal to true. So we'll assume that it's true, and we'll set it to false. Basically, I'll iterate through all the nodes, and if I ever see a node that's unbalanced, I'll set this to false. And then at the end, we can just return whatever this value is. So that means I need to traverse the tree and consider every node. And I think I'll do a pre-order traversal. I don't think it matters too much. But what I can say is a pre-order traversal means I visit the node first. So visiting the node means that I would calculate all of this first. Like so. And actually, I can simplify this. I could just put in depth of root dot left, depth of root dot right. I don't need an extra step, just to make that easier. And I don't need to return yet. So this would be the is balanced equals that. And I can simplify this. I can say if, in this case, I'm going to change it. So if we see that the difference is greater than 1, we know that this is unbalanced. So we can set self.unbalanced equal to false, because we saw an example of a node where the difference is greater than 1. Then what we need to do is iterate over the rest of the nodes. So we can do that by saying if node.left, we can call traverse node.left. And similarly, if node.right, we can call traverse node.right. Perfect. So then, if not root, we can return true. Otherwise, we can say traverse the root node and then return self.unbalanced, like this. Let's quickly see if that works. So that did not work on the last case. I'm going to stop using this un. I'm going to make it, I'll just make it normal balanced. Self.balanced will assume true, but if we ever find that it's not, we'll set it to false, and then we just return whatever that is at the end. Okay, that makes a lot more logical sense. But that's still failing the last case. Let me submit the whole thing. Oh, I know. I put root instead of node there. This, I do this every once in a while. Sorry, everyone. So root needs to be, I need to pass in a root out here, but inside of these functions, I'm calling it node, and I put root. Sorry that I missed that. Perfect. So that should be working, hopefully. Before I submit, I think there's one extra thing that I could do to make the code run a little bit faster. Once I find that it's false, I don't have to keep going, if that makes sense. So what I could do here is add one last check and say if self dot balanced. So if not self.balanced, I can just return. And the reason I can do that is because once I set this to be false, we know the whole tree is unbalanced. If I see any case where it's unbalanced, I know the whole thing is unbalanced. So by adding this check here, I think what that'll do is save me from doing a lot of recursion steps when I don't need to. Make sure that still works. Okay, great, and let's submit that. Okay, great. So that worked. I'm happy with that solution. We got to use the depth function again that we've used so much in the last couple of videos. And yeah, this is a pretty clean solution. I'm not sure how much runtime this actually saved me, but probably some. And thanks so much for watching. I will see you in the next video.